So as we cover the scientific revolution, this lecture in itself will be covering these three topics: astronomy, alchemy, and biology. Um, it's important to know that everything that we've been covering, we have released recently. The scientific revolution is embedded within this time. So, the range generally is around from 16th century to 17th century. So as we are in the middle of absolutism, and even in our next section, we go to Eastern absolutism, all of this is still happening, and the developments and the findings in science are going to be influencing society, obviously, but definitely a lot of the political leadership in terms of how they are going to invest and support these type of scientific researches. Okay, so let's just talk about a little bit of background as an introduction. The scientific revolution, especially towards the end of it in the 17th century, is going to be adding an intellectual component to Europe, where we call this time the Age of Genius. Okay, before even there was the subject of science, for the most part, it was associated as natural philosophy. And so, if you are a scientist before the 19th century, they called you a philosopher, and you're the one who is to establish theories of the physical world and the universe and the stars and the earth. And it's not until the 19th century where science as a subject is actually, distinct from its philosophical ties. And so natural philosophy was kind of the terminology used to refer to science at that time. Okay, a lot of it was theoretical. Okay, the significance also that we're going to see the scientific revolution is going to bring is that Europeans are going to be experiencing a totally new view of the universe, where obviously they're shifting the way that they see the world. Once was Earth-centered, but now it's Sun-centered, right? Earth is now just another planet, and the Sun is just another star. Whereas before, right, from the thinking of the Greeks, and even from the thinking from the church from the Middle Ages, the Earth had extreme significance because it was God who created the world, and the world, meaning Earth, right, was where everything held its purpose, right? So everything revolved around what God created, which is the world. And so we're going to see there's going to be a transformation in the purpose of humans, where their place in the universe is no longer as significant anymore. Now, humans are still important, but they had to rethink a lot of moral and religious matters, because the idea of science coming in really challenged the views of the Catholic Church. And so society, which once was very much dictated by the doctrine that the church held to, they needed to find a way where they could really reconcile between faith and reason. Faith and science, need to find kind of a new type of marriage in seeing these new theories to be accepted or rejected by the Catholic Church. If you kind of remember, scholasticism during the Middle Ages came as a development, but that was just using faith and logic, where this as adding in that science component, where there's experimentation and it's more about your actual observations, your actual research and finding of the physical world around you. Okay, all right. So we're going to see Europe go through a transitional time, right? So by adopting this new worldview, this perspective is going to lead Europe to become much more secular, much more rational, and focus upon the materialistic world. So very much leaving, right, the God-influenced, church and faith-influenced worldview and adopting more of a secular one. And this is really going to carry into Western thinking into the 19th and 20th century, adding on to that science and technology is going to build on top of this revolution, right? And by seeing this, it's going to take some progress of time, right? Centuries happen, time and time, right? It's not easy, right? There's a challenge to it because it's a little by little gradual process. People don't want to accept changes overnight, right? They have to really think about it, right, and chew and digest these new ideas. So this revolution was what we call a gradual revolution, right? So in the end, the results of the scientific revolution completely overthrew the old traditional worldview, but it was a gradual thing. Okay, it wasn't an immediate thing. So the results were made a huge impact, overturned a lot of things, but as explosive as it was, in contrast to the way things people saw before, it was in practice a very gradual process. Okay, so even though there's many people that we're going to be covering and stuff, there's some names that are really more important, and these are just some of the locations that hold significance that have generated a lot of these scientists to contribute to European scientific development. Okay, so you have Poland, Italy, Bohemia, Denmark, France, Great Britain, and of course there's always more, not as famous people, but that's okay. Those are the ones we're covering. Okay, so what caused the scientific revolution? Well, if you look back in terms of what were the things that influenced this type of thinking in general anyways? Well, some of the places are the universities. So remember, during the late Middle Ages, you have the medieval universities that are obviously encouraging studying and research. And so by 1300, philosophy was an accepted discipline alongside with law, medicine, and theology. And these universities were the ones to lead these new professorships and looking into the more specific subjects of mathematics, astronomy, and physics. Okay, a lot of natural philosophy, and all of these kind of fit into the philosophy department. But eventually, they would have their own professorships and scientists and philosophers studying in these areas. And so, universities was just the place where things were taught and things were learned. Okay. The Renaissance was a time period where it led to a lot of new works based upon the inspiration of the Greco-Roman era, the classics, and you have a lot of big names like Aristotle and Galen that are used in the Middle Ages, and those are the two names that we're going to hold on to, and I'll explain more about that. But that's where a lot of scholars went back to and said, hey, you know what? They use a lot of logic and analysis in their theories. They didn't use a lot of observation or experimentation, which will be the biggest difference in the scientific revolution. But because of them, right, they were inspired and they began to study more as well too. Okay, the Reformation also was a time period that represented a break from medieval thought and just always holding on to old doctrines and thinking, but to have a questioning spirit, right, to protest, right, and to look for what is truth and what is, reality and what should be held to the higher regard. Okay, and then you have the Age of Exploration, where Europeans are going to explore the world and acquire new knowledge from the people that they have first met, right? And these foreign peoples, these indigenous peoples, have introduced new plants and animals different from their heritage, European heritage, and also the experience of navigating the blue waters, right? And so on the oceans and seas, they would go upon these voyages, and they needed to rely upon a lot of these scientific developments in a lot of the tools that they used, right? And also engineering and calculations and developments in math as well. Okay, new technologies are introduced, as I mentioned before. Okay, one is going to be the telescope, but also you have other types of tools such as a microscope and the printing press. Okay, these were developed outside of universities, and some of these tools are really different from before because a lot of artisans and craftsmen would aid in the construction of new instruments. You might have a person that has a good theory about how maybe the world works in physics, right, or in anatomy, but they don't really know how to construct a tool. So that's where a craftsman comes in, and they kind of work together. So one may have the practical knowledge of building something, but they have no idea of what use of it is, and the other person has a theoretical knowledge and understanding how maybe the body works or how gravity works. And because of that, together they're able to create these new technologies. Okay, Renaissance artists began to accurately paint nature in a very realistic way. The human anatomy and the features of the human body using geometry and perspective right? It's really adopting more of a scientific approach and looking at things, right, proportionally. Okay, math is going to be developed as well because you remember for Leonardo, he would pretty much come up with his own inventions and engineer them, right? And so he may not have built all of them, right? But he really wanted to create these things that could eventually be built one day. Okay. All right. So I wanted to introduce kind of one more just further point, understanding it visually. Okay, in terms of how did the scientific revolution really bring forth change? So if you look at this flow chart, new knowledge in medicine, chemistry, history would come through the scientific revolution. However, we're going to see that astronomy is going to be one of the main topics that science will kind of spring out forward, and seeing how it's going to be a complete contrast to medieval scientific thought. So previously, science before the 1500s was very much based upon how the Middle Ages dictated it, and it was primarily religious and theological. And so science was essentially kind of like a branch of philosophy and theology, because if we look at this diagram, you have two Greek guys, Aristotle and Ptolemy. They and their theories influenced what the scholars during the Middle Ages held as the real worldview. And from that, okay, scholasticism would have certain topics. One would be philosophy, the other one's theology. Very much close in really understanding something, right? How does the world work, but also how does God work? And because those are very close in mind, science was under God, right? Science was under the church, and the church was the one who really dictated how people should perceive science. That will all change as new theories would come up. Okay, so let's talk about under astronomy. How was the medieval thinking according to the church, and how the world worked and the universe worked? Okay, so the scientific revolution is going to challenge the orthodox, the traditional, the medieval view that the world was driven, right, by a geocentric system. So you have Aristotle and Ptolemy combined with a lot of Christian theology that hold that the geocentric view believed that the Earth was at the center of a static and motionless universe. Okay, so say it one more time. The geocentric view held that the Earth was at the center of a static, right, non-dynamic, not moving, right, non-changing, remaining the same, motionless universe. And so the universe essentially held these what we call concentric spheres. So kind of going back to geometry, right, where you have a bunch of different other spheres within circles, right? They're fixed, they're motionless. Earth is not moving. Okay, everything else around it is moving around the Earth, and then there are just four elements in the world. You have earth, fire, air, and water. Okay, and the spheres that surrounded the Earth were made of these crystalline and transparent substances, and they called those just other spheres. Okay, and those things moved in orbits around the Earth. The Earth is fixed, and from there you have 8 spheres that included the Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, and then you have other fixed stars. And those are the other spheres around it. They didn't really call them planets at the time. Okay, but then you have a couple other spheres. You have the 9th sphere, which is what gave the fixed stars its motion. Okay, and then you have the 10th sphere, what they called as the prime mover, that gives motion to the sphere. So this is a little confusing. You don't need to know this too detailed, but just understand that this was kind of the geocentric theory, and they were kind of detailed in their understanding, right? Beyond the 10th sphere, though, you have what we call basically heaven, and that's where God is, and that is kind of playing into this medieval point of view, where God and saved souls were at the end, at one end of the universe, and the humans were at the center, that they were on Earth, right? And so the real goal is to achieve salvation. If you are able to achieve salvation, then you can go and reach the heavens, which is outside the 10th sphere. Okay, So a lot of astronomers would look at this theory and say, you know, I don't really quite agree with this because according to my observations, I don't feel like the Earth is fixed. Okay, but according to the geocentric theory, that is what they held to, and they believed that planets would travel what we call in epicycles, which are basically within a sphere they would turn and orbit in their own circles as well. Okay, and so here is an example of epicycles where you have the geocentric view of the world, right? So you have Earth in the middle, okay, then you have the moon, which is that black dot, and then you have like a planet that's going around in an epicycle around and orbiting around the Earth like that, okay? So who will challenge this? Our big name you must know is Nikolaus Copernicus, okay? He is Polish, and he studied math and astronomy. A little bit of background, so he's part of late 15th, early 16th century, and later he'll study in Italy, study math and astronomy, and he began to see that a lot of things that he learned would contradict the Ptolemaic or the geocentric view. Okay, he wrote a book called On the Revolutions of the Heavenly Spheres, and he actually did not publish it right away because he had a lot of fear that other astronomers would ridicule him because he was really challenging what everyone else held to for 1,000-some years as the true theory. Okay, shortly before his death, he would publish a book. He dedicated the book to Pope Paul III. He didn't intend to be like shove it in your face, like Pope Paul, check this out, to challenge the church, but he just wanted to reveal what his theories and studies and observations were. Okay. All right. So his theory is the heliocentric theory, so it's in contrast to the geocentric. He held the view that the sun was motionless. The sun was the center. Okay, helio meaning sun, and the solar system had stars and the Earth that are orbiting in space around the sun. Okay, so because of this, adopting this point of view, he saw that the universe now seemed to be, and everyone else said that the universe now is an enormous and perhaps infinite place that you could not really understand and see completely. Okay, and so basically he was pretty much a conservative in the sense that he didn't reject Aristotle's view of the heavenly spheres. He still held to that, right? But he actually just felt that that it's just the sun is in the center, and because of this, many people began to see that, hey, you're challenging more than just a theory, right? You're challenging the book of the Bible in Genesis, where God created the world, and the world was important, not so much the sun and stuff. Okay, so those who would challenge first are the Protestants. The Protestants, such as big names Luther and Calvin, saw this and condemned Copernicus for saying that, according to biblical passages, right, you're going against and turning basically the Bible upside down, and you're a heretic. Okay, and so that is kind of what the Protestants felt of Copernicus, and later on there will be some reconciliation with that. Okay, all right. So our next guy is Tycho Brahe. I think a pure American could say Tycho Brahe, but that is what his name is in Danish. Okay, so he's a Danish guy. He's part of the 16th century. He was an astronomer that studied math and astronomy and focused on watching the stars a lot. And he wanted to just kind of see a lot of different types of supernovas and really rare situations in space, such as a solar eclipse. Okay, so just as a background, that's what he studied. He had some interest in politics. He had some interest in alchemy and astrology, but he's really known for his astronomical findings. Okay, so in 1572, a supernova came, and this burst into his view through a telescope, and he saw that this star, the supernova, became brighter than the planet Venus, and it was visible for about a year and a half, and that was termed to be Tycho's star. Okay, and he wrote a book on it called De Nova Stella, which means concerning the new star, and he linked from that point on in his study of stars that nova meant to exploding star. So he equated those two words together. Okay, he was very arrogant, and Frederick II, the King of Denmark, actually was his patron and would pay him and allow him to build an observatory on the island of Hveen. This is where we have the first astronomical observatory. That's what he's known for. He built his own castle as an observatory, and then one castle specifically for residents. All this stuff's not that kind of important. The main idea is that he would actually put in a lot of time of observation. Copernicus, okay, really just mathematical, logical, and just felt that the old geocentric view was wrong. Brahe is going to reject the Ptolemaic system. That's one thing that makes him significant, is that in his observations that took for over 20 years, he looked at the different positions of the planets and the stars and says, you know what, I reject Ptolemaic system as well. So that's what they have in common between Brahe and Copernicus. However, he does not accept Copernicus's view of heliocentric system because Tycho Brahe believed that the sun, though at the center, still revolved around the Earth. Okay, so Johannes Kepler is going to be his assistant that he's going to pick up, and at that point, that will kind of reconcile Copernicus and Brahe together. Okay, all right. So this is Tycho Brahe's view that if you look at the Earth is still at the center, you have the moon right outside of it, right? But everything according to the blue little shaded one circle, sorry. That is where the sun is revolving around the Earth still, okay? But around the sun, around what is the kind of orange, yellow-orange, right, you have all the planets and the stars that are revolving around the sun. And that's kind of, yeah, his view, and then everything else is the fixed stars around that with the blue, royal blue stars, okay? All right. Let's talk about Kepler. Okay, so Kepler, he's a German guy, mathematician as well. These all are like math, astronomy guys. He's a scientific genius, and one thing to know that he is Protestant. Okay, Kepler, his assistant, Brahe's assistant, kept the observation that Brahe had, but he carried on and reconciled Copernicus's theory. Okay, so he had 3 laws. Okay, and he was able to calculate these 3 laws of planetary motion. Okay, he says that first, the path of the planets was obviously they're orbiting around the sun. However, it's not in perfect circles, but in ellipses. So as you guys know, kind of from math analysis, a little bit of algebra 2, right? Ellipses are not perfect circles, more oval shape. So that was the first one. The second one is that planets do not move at one speed in their orbits. When they get closer to the sun, okay, they begin to get a little bit faster in their orbiting in terms of speed. And the third one is, these are all calculated, okay, that the law dictates that when a planet is orbiting the sun, depending upon the distance from the sun to the planet is obviously, not obvious, but according to him, is proportional to the time it takes for that planet to revolve around the sun. So because, right, Mercury is the closest to the sun in distance, right, it has a faster time to reach its orbit, whereas if you imagine, let's just say, Earth or Jupiter that's farther out, because it's a farther distance, proportionally it's going to take a longer time, but it's proportional to the distance, okay? All right, so the significance is that because of these laws that can be calculated according to the equations and formula that Kepler has devised, okay, not that we need to know what the formula is, it's able to show that mathematics and facts of the actual world can be accompanied to and corresponded to the observations. So the calculations that he's making and the observations all coincide and meet together well. Okay, so there's a cosmic mathematical relationship between space and also time. And as you look at this little line drawing, this is a diagram of Kepler's model of the solar system. This is the supernova that Kepler, shooting star that he witnessed of a comet, when he was a kid. Okay, all right. So alchemy, really interesting. Just to kind of give a little bit of background, chemistry wasn't the original way that people saw like materials and metals and stuff. It was really alchemy that first started, and because there was a drive where people believed in this myth of a philosopher's stone. If you guys remember Harry Potter and the Sorcerer's Stone, that's kind of like the special stone. They just changed it to sorcerer because it's more magical sounding, but philosopher's stone is the original myth. But this stone essentially basically can turn any base metal into gold, and obviously gold is highly valuable. Okay, so they believe that by using the philosopher's stone, you could speed up the chemical manipulation, turn things into gold, make it rich, super happy. But most alchemists actually weren't pursuing the philosopher's stone. That was just kind of more of a myth. Most alchemists were trying to apply chemicals to medicine, hoping to cure diseases and to make drugs, right, to bring remedies and healings to people. Okay, so you can see a bunch of different images here of the philosopher's stone, but also a lot of alchemists in the lab, and they have a lot of assistants and stuff helping them. Okay, a couple of individuals that are really important. The first one is Paracelsus. He's going to be one of the most controversial figures of the early 16th century because of his ideas of challenging Galen. Okay, so Galen is previously ancient Greek scientist who studied kind of the body and anatomy and that kind of stuff. Basically, Paracelsus is controversial because he wants to overturn 1400 years of the Galen research dominated medicine, okay, that started from Aristotle to Galen. Okay, Galen believed that disease was the imbalance of four body fluids. Okay, blood, bile, that's yellow color, bile, that's black color, and phlegm. Okay, so there are four bodily fluids, and he believes that basically each one represents a good thing or a bad thing, and if there's an imbalance of one, it leads people to be a certain way, right? So if you have more blood, that's good, you're cheerful. If there's more yellow bile, you become more violent. If there's black, you become really depressed, gluttonous, and lazy. And if you have a lot of phlegm, then you become more cowardly. So those things dictated, right? So Paracelsus really wanted to challenge this. He was associated to be the father of toxicology. And because before Paracelsus' time, right, people really believed that by doing a process what is called bloodletting, right, and sweating to correct the imbalance of these fluids, right, doctors would let blood out for a period of time, allowing the balance of the fluids to come through. Paracelsus says, hey, that's all junk, okay? And he says, you know what, new diseases demand new cures. It's not just, oh, one of the four body fluids are out of order or imbalance, but he says that each disease has a cure that needs to be remedied. And so he believes that by consuming particular chemicals, then, you know, it's going to allow a cure to happen because of the reaction of your body. So he would even suggest of ingesting mercury, right, lead, arsenic, and this was a little far-fetched because those are all metals and that would probably kill you, right? The Galen method really was no longer accepted because, you know, diseases like syphilis would appear and people didn't quite understand, well, it's not the fluids, but people were still getting sick. And one last thing about Paracelsus was that he came up with the element zinc with a K, but it's labeled as zinc, Z-I-N-C, okay? All right, so let's talk about a couple of other major guys, science guys. Chemist is Robert Boyle. You guys probably heard about him in your chem class. He's an Englishman. He's going to establish the basis for chemistry, okay? he is going to say chemistry is important not because of alchemy, not because of changing metals into gold, but because it is used for medicine, right? And so he wrote the book The Skeptical Chemist, and it's a foundational book still today for a lot of chemistry students. He's going to reject Aristotle. He's going to reject Galen and Paracelsus. He believes that the atomic matter, right, is significant because it actually is the elements of the world, right? So all the chemical elements in the periodic table, he is explaining that the atomic matter equates to different elements that exist, okay? His most important experiments were used with gases, and then he devised the Boyle's law, as you guys maybe have used in chem class, right, which is the relationship between volume and pressure of a gas. And he also invented the air pump, as you see here. Okay, you don't necessarily need to know how Boyle's law is making a huge significance in this course, but overall, just know each guy had a contribution. You got to name drop a couple, as this is, you know, intellectual history compared to maybe some of the artists that we've studied in cultural history. Okay, a couple more guys, right? Andreas Vesalius, he is what we call the father of anatomy. A lot of medical sciences would advance through the scientific method, and anatomy, the study of the body, is one of them. Okay, he wrote a book, The Structure of Human Body. He had a lot of sketches of the human body, as you can see here on the right. Okay, and he had a passion to renew and modernize the study of human anatomy. So he is doing these anatomical drawings, and he is able to do them so accurately because he begins to perform dissections on dead humans, and that allows him to see things clearly. Now, the Catholic Church obviously was never for this, and so he's opposing what the church would support for the sake of science. And the church is against it because, you know, that's dealing with corpses, right? That's highly superstitious in touching dead things, and, you know, like the whole spiritual aspect to that, they don't support, okay? So being a Belgian guy, he actually was doctor to Charles V. That's one thing that is important in the significance of how he was able to get so much research, okay? All right. William Harvey was doctor to James I and Charles I, English guy. He wrote a book called On the Movement of the Heart and Blood, and he explained how blood was pumped by the heart and circulated throughout the body. Okay, before him, okay, most believed that blood was circulated through the liver, not through the heart, and it traveled from the right side to the left side through certain pores. Okay, but through Harvey's research and dissection and all that kind of stuff, he found out that the heart is actually a pump, right? And through the pump, there are valves that let in blood and push out blood and allow the blood to go and flow through one direction, and then the whole body is getting blood circulated appropriately, okay? And later on, he's going to have other people verify this by looking through a microscope and seeing that there are capillaries and blood vessels within the heart, okay? Our last guy, so here we go, Antony van Leeuwenhoek. Okay, he's a Dutch guy from Delft, and he is known to be the father of microbiology because he is going to be implementing his own microscope. And he didn't really have a science background, but he learned how to grind lenses in Holland, and over time he's been able to look through his microscopes and discover bacteria, okay? He first discovered bacteria by examining plaque on people's teeth, but through his discoveries, he did not make the connection himself that bacteria eventually is what is going to lead to infections and disease. Okay, that'll take some time later. But the microscope was a huge tool that was used to see single-cell microorganisms, and later on, the microscope method is going to be used and improved by Galileo after Leeuwenhoek.